In January 2019, a cotton seed began to take root, sprout, and grow leaves on the moon, making it the first time for humans to cultivate plants there. This miraculous experiment took place inside China's lunar probe, Chang'e 4, in a sealed container. When we look up at the moon, we may not realize that many unprecedented exploration of deep space are underway. Right up there. Chang'e is the serious name for China's lunar probes. In Chinese legend, Chang'e is a fairy who flies to and makes her home on the moon. To ancient people, the moon was an unreachable place, making the story both romantic and bold. Today's China's lunar exploration program is gradually making the ancient myth come true, making Chang'e undoubtedly the most appropriate name for this probes. This time, Chang'e 4 has the bolder goal than its predecessors, landing on the far side of the moon.
月球有正面、有背面、有中纬、高低纬。我们做月球探测的研究，当然是希望能够到达月球上尽量多的地方。其实去月球背面探测是各个国家科学家和航天工作者的一个梦想吧，都是想去的，因为去背面肯定有更多的新的发现。
In 1959, the Soviet Union's Lunar 1 became the first artificial probe to approach the moon, marking the commencement of human lunar exploration. Same year, the Soviet Union's Lunar 3 probe made the first flyby of the moon's far side, capturing photographs of this previously unexplored region.
These images let us know that near side and far side of the moon have two distinct faces. And beneath these two faces lies the significant difference in scientific exploration values. Exploration of the far side is indispensable. However, before the Chang'e 4 mission, none of the 20 previous lunar landers had landed on the far side. Why not? To answer this question, we need to first look at the relationship between the Earth and the moon.
This is the hammer throw. As the athlete starts to spin the hammer, you can imagine the athlete as the Earth, the hammer at the other end as the moon, and the chain as the gravitational force between them. As long as the spinning doesn't stop, the hammer will always have only one side facing the athlete. The relationship between the Earth and the moon mirrors this dynamic.
Imagine this ball is the moon with a diameter of 3,500 kilometers. No radio signal from Earth can penetrate the spherical body and reach the far side. It's a significant barrier for human missions. Without signals, probes or rovers on the far side of the moon cannot receive instructions and are unable to operate. Even if a successful landing is achieved, data and images cannot be transmitted back.
To become the first probe to land on the far side of the moon, the Chang'e 4 mission had to overcome this challenge first, establishing communication between Earth and the far side of the moon.
reach the far side of the moon where a communication signal cannot be directly received, Chinese scientists need technology and a bit of imagination. And when it comes to the moon, the Chinese have never lacked imagination. Over 1,000 years ago, China's most famous poet Li Bai penned the verse, "I raise my cup to invite the moon, and together with my shadow, we become three." The lonely poet invited the moon to drink with him, and in the moonlight, his shadow was imagined as a third companion toasting together. Light, shadow, and projection brought romance to the poet and inspiration to scientists.
Over a millennium later, Chinese scientists have made a remarkable discovery: the third companion. 6 months prior to the Chang'e 4 mission's launch, China's lunar exploration program introduced a communication relay satellite known as Chang'e, or Magpie Bridge.
今天凌晨的5点28分，我国在西昌卫星发射中心用长征4号丙运载火箭成功将嫦娥4号任务鹊桥号中继星发射升空。
这是世界首颗运行于地月拉格朗日 L2 点的通信卫星。
国际上在以前也都有过要去月球背面的一些畅想，但是在上个世纪嘛，60、70年代，其实我觉得主要还是首先是中继通信技术不具备。其实真正整个航天就是中继通信技术，大概也是在上个世纪90年代才具备的。
Well, possessing the necessary technology for relay communication is crucial. The Chang'e 4 team is still grappling with the challenge of selecting the optimal orbit for enhancing relay communication on the far side of the moon.
我们要选择这个中继星工作在什么样的轨道，它既能看到月球背面，还要能够看到地球，实现这样一个通信的中继，可以是环月的轨道，也可以是到这个拉格朗日2点。
The advantage of a lunar orbit lies in its close proximity to the moon, typically within a range of 100 to 200 kilometers. However, it comes with a drawback. It cannot maintain a constant facing of the far side of the moon. The Lagrange points, also referred to as liberation points, are a set of 5 positions in a system of 2 large celestial bodies as per theoretical principles. Similarly, there exist 5 such points in the space between Earth and the Moon. Near the Earth-Moon Lagrange point 2, situated approximately 400,000 kilometers from Earth and 60,000 kilometers from the Moon. The gravitational forces between the 2 celestial bodies are in relatively stable equilibrium. This unique balance allows relay satellites to operate with minimal fuel consumption, making it an ideal location for effective communication.
当时我们也是经过论证多次的这个比较呢，现在我们选择的这个 L2 点，我们设计了一个围绕它运行的一个叫运轨道。
它就是始终看着这个月球背面和地球，同时可以看到，所以这一点呢，就是可以实现全实时，就是不间断啊，整个中继弧段一直是连续的。
By the end of 2018, Chang'e 4 had successfully entered its designated orbit and established a communication with the ground using the Chang'e relay satellite. Humanity had ventured onto the far side of the moon, with only the flawless landing left to accomplish. At a distance of 15 kilometers from the lunar surface, Chang'e 4 began to decelerate and descend. The entire landing process lasted approximately 690 seconds.
690 seconds, or 11 and a half minutes. This period of time was both long and short for the Mission Control Center. The 1-ton-plus Chang'e 4 lander didn't descend in a straight line. It had to maneuver and adapt on a go. You can imagine it as the massive, remote-controlled game of Tetris. You have one chance, and one chance only. Locating a relatively flat area is paramount for the safe landing of Chang'e 4. If the lunar surface is excessively rugged,
it could result in a failed landing.
月球背面比月球正面更崎岖。大家如果看那个月球的那个图像哈，咱们以前有遥感图像，背面都是密密麻麻的那种坑，很难找到一个大片比较平坦的地方。那我们整个的控制的精度就要很高，轨道的控制调节。同时，最后刚才也说到，我们要有自主的避障。
The Chinese approach involves the probe briefly hovering 100 meters above the lunar surface, utilizing this brief moment to activate the probe's autonomous obstacle avoidance system, effectively avoiding uneven terrain.
我们在整个的这个着陆过程中是靠我们自身携带的敏感器啊，距离月面100米的地方呢，高度处呢来进行悬停的这个对于地形的进行这个测量，然后识别出这个满足我们着陆的区域，然后再进行着陆。
It may not sound complex. The process involves using instruments for measurement, calculation, adjusting the probe's orientation, and finally achieving the landing. But how long does the probe hover? Just 3 seconds. It's within the brief 3-second time frame that the autonomous obstacle avoidance system must complete all necessary measurements and calculations. At Chang'e University, researchers have discovered a method to accomplish this task within 3 seconds. In their testing facility at Chang'e University, boards of varying sizes and angles are used to simulate the undulating lunar surface when viewed from above, effectively validating the accuracy of laser imaging technology.
20.78.2937，做了大量的实验，就是底下的场景在不停地发生变化，然后再看一下我们是不是真落到安全着陆的那个区域了。但这一块大小其实也就是我们一个光斑的20公分那么大小。对，是的。
However, no matter how high the precision in ground-based statics experiments, it cannot account for the probe's movements during actual operations. It's like taking photos in a bumpy car, resulting in poor image quality. The solution of Xu Rong's team is speed.
之前我们的方向标定，或者是标定，
因为我们速度足够快的话，你平台在晃，对我来说就可以忽略不计了。照相机大家知道，在一个高速运动上面，要把快门要给它变得非常短，你的手抖都不要紧，我就把时间给它加快。所以我们当时提了一个用16个波束，相当于说16台激光器同时工作。效率就提高了16倍，就会非常的快，能够在250毫秒里面就拍一张3维图。
The autonomous obstacle avoidance capability of Chang'e 4 helped it steer clear of dangerous areas, enabling a successful landing on the lunar far side. The landing site was situated in the center of Von Karman's crater within the Aitken Basin at the moon's south pole. Merely 76 minutes after the touchdown, the Earth received the first image taken by the probe, all thanks to the Chang'e relay satellite. Images were sent back one after another, showing uniform desolation everywhere. However, beneath this barren surface, there might be numerous secrets waiting for humanity to explore. Chang'e 4 was designed for a 12-month operational life, while its companion, the Yu-22 rover, was anticipated to function for just 3 months. For those observing from Earth, this duration might appear brief, especially considering the significant efforts to reach the moon's far side. The question arises, why wasn't a longer exploration period planned? The answer is the extreme conditions of the lunar environment, which pose significant challenges that are hard for humans to fully understand. The moon's surface experiences extreme temperature fluctuations. During the lunar day, temperatures can soar to 160 degrees Celsius.
In the night, they plummet to frigid minus 190 degrees Celsius,
resulting in a staggering temperature swing of over 300 degrees. Such drastic changes significantly impact the longevity of electronic and mechanical components, limiting their operational lifespan in this harsh environment.
The lunar rover brought to the far side of the moon by Chang'e 4 is China's second, named Yutu 2. In Chinese mythology, Yutu is the companion of the moon goddess Chang'e, a cute, cuddly rabbit. But its 21st century namesake need to be tough and powerful.
Besides contending with extreme temperature fluctuations, Yutu 2 must navigate the moon's intricate terrain. The lunar surface beneath the rover is the treacherous landscape of pits and ridges, where a single misstep could leave Yutu 2 stranded, prematurely ending its journey of exploration.
探测器在月球表面必须要有很好的热控和太阳能源获取的条件。太热的话，它还在工作的话，就会把仪器烧死。太阳出来要15度我们才开始工作。要落山之前15度，我们基本上就要关机。
When the moment is right, Yutu 2 will awaken and conducts its exploration within a constrained time frame. It delves into the mysteries of the lunar far side, navigating the harsh and uneven terrain of the moon's surface. Scientists at the National Astronomical Observatory have utilized the Yutu 2 rover's onboard scientific instruments to conduct extensive surveys of the moon's far side. Since its landing in January 2019, Yutu 2 has surpassed its initial 3-month operational expectancy. As of September 2023, it has traversed more than 1,500 meters on the lunar far side
and transmitted over 1 terabyte of scientific data back to Earth,
providing valuable insights into the moon's topography. The Chang'e 4 mission, marking humanity's first landing on the lunar far side, has captivated scientists globally.
当时应该有11家这个国外的这个单位吧，提交了这个搭载的一个需求，其中一家是包括跟我合作的这个瑞典空间物理所。
It offers a prime opportunity for collaborative research. What hidden opportunities does the lunar far side hold?
You might have never given a thought that just how much scientists wanted the lunar far side for an astronomical observation site.
In 1609, Galileo crafted the first optical telescope for astronomical observations. But he probably never imagined that, centuries later, telescopes could evolve into what they are today. The 500-meter aperture spherical telescope, also known as FAST, is the world's largest single-dish radio telescope. Its vast dish covers an area comparable to 30 standard soccer fields.
Radio telescopes are called the eyes of the universe. They are enormous, precise scientific tools used to observe celestial bodies, galaxies, and other distant phenomena. Unlike traditional optical telescopes, spherical radio telescopes use radio waves, which can penetrate clouds and overcome the limitation of the Earth's atmosphere, capturing more information hidden deep in the universe.
FAST is nestled in a natural basin, its terrain seamlessly complementing the telescope structure and easing construction challenges. But the primary reason for selecting this site was to minimize electromagnetic interference. China embarked on constructing this monumental telescope in 1994, dedicating over a decade to meticulous site selection. Encircled by mountains and sparsely populated, this area ensures minimal electromagnetic disturbance, crucial for capturing pure astronomical signals. Since the advent of radio telescopes in 1937, the radio astronomy community has grappled with the significant obstacle: low-frequency radio signal observation. The frequency band of 3 to 30 Hertz, known as the very low-frequency cosmic radio signals, carries vital cosmic information. However, due to Earth's ionospheric shielding, the signals are nearly impossible to observe from the ground. In their quest for clearer signals, radio astronomers are now looking towards the moon. But the question remains, can we truly capture pure signals there?
But this was all just speculation until we could prove it. The human mind has no boundaries, and the speculation has no limits. But science needs evidence.
之所以要去月球背面，实际上最重要的这个科学目标，就是要去做低频的射电观测，利用月球本体良好的这个遮挡了，就是它是一个非常好的一个屏蔽体。
Relying on the moon's immense volume with a diameter of 3,500 kilometers, interference signals from Earth can be completely isolated. Very low-frequency signals from the cosmos will be received by humans in their clearest form, making it an ideal place for radio observations. The moon, an object observed by astronomical telescopes on Earth, has become a new site for us to conduct astronomical observations of the deeper universe.
In the traditional Chinese calendar, months are marked by the cycles of the moon. There is the poem in China that goes, "The moon is bright or dim, and she may wax or wane. There has been nothing perfect since the olden days." This poem expresses the Chinese worldview that everything has its completeness and regrets, and there will always be ups and downs. This perspective applies to the journey of human lunar exploration as well.
From 1959 to 1976, humanity experienced the first peak of lunar exploration. Over nearly 20 years, the Soviet Union and the United States successfully launched hundreds of probes to explore the moon. In 1966, humanity's probe made the first soft landing on the lunar surface. And in 1969, humans set foot on the moon for the first time.
When humans landed on the moon, they found nothing but dirt. No signs of life at all. But don't be disappointed, because in the eyes of scientists, dirt matters. In many previous lunar missions, bringing back lunar soil was a significant achievement and a symbol of the first wave of lunar exploration.
Finally, in a field where the United States...
In the 1960s and 1970s, both the United States and the Soviet Union collected lunar samples. Bringing back lunar soil to Earth was indeed a surprise for all of humanity. The technology had never advanced so rapidly. However, the first climax of lunar exploration came to a hasty conclusion in 1976 when the Soviet Lunar 24 probe returned lunar soil samples for the last time, and the moon fell silent. For nearly 2 decades afterward, no human spacecraft visited the moon. The excitement brought by the first climax of lunar exploration has never faded, making a return to the moon inevitable. As time moved into the 1990s, human probes finally returned to lunar orbit. In 1998, NASA released mapping data from the Clementine mission. This probe discovered evidence of possible water ice in a permanently shadowed area of the moon's south pole. This discovery caught the attention of space agencies worldwide, increasing the possibility of establishing human bases on the moon. Returning to the moon began to turn into action. The second wave of lunar exploration began. Major space agencies around the world announced their lunar exploration plans. In the early 21st century, NASA proposed a constellation program to return to the moon. Developing the Orion spacecraft, the Altair lunar lander, and new rockets, with a goal of achieving a manned lunar return by 2030. Russia is vigorously developing the Alio spacecraft and plans to conduct circumlunar experiments in 2029. New players continue to join the space exploration in the new century. In 2003, the Indian Space Research Organization announced the Chandrayaan-1 mission. And the European Space Agency launched its first lunar probe, SMART-1, which arrived at the moon a year later. At the beginning of the 21st century, Japan's new moon mission, Chang'e, entered an accelerated development phase. As the major space power, China is also steadily advancing a grand plan. China's space endeavors began during the first climax of human lunar exploration. In 1970, China successfully launched its first satellite, Dongfanghong-1.
China's space program started a bit late, but has been evolving at a surprising pace. In the following decades, the development of China's space sector has repeatedly impressed the world. In 1971, China launched its scientific experimental satellite, Shenzhen-1. This was followed in 1984 by the successful launch of the country's first experimental communications satellite into geostationary orbit. The advancements continue in 1988 with the launch of the Fengyun-1, an experimental meteorological satellite. In 1990, China further demonstrated its technological prowess by successfully launching the Long March 2E, a newly developed high-thrust carrier rocket.
In November 2000, as call for a second global wave of lunar exploration grew louder, China released its first white paper on space activities. There was just one sentence about the moon: conduct a preliminary research for deep space exploration with a focus on lunar exploration. This was a modest announcement. Over the 30 years of space exploration, China had achieved a success rate of over 90% in satellite launches. The Long March rocket series had expanded to 12 models, capable of sending up to 9 tons of payload into low Earth orbit. In 2003, the Shenzhou 5 spacecraft carried astronauts into Earth orbit and returned, demonstrating that China's space program has established a comprehensive technological system. Looking back at the history of human space exploration, China's next goal became clearer: the moon.
我们中国刚好赶上了第二次探月高潮，那就是20世纪末到21世纪初这个阶段。这个时候，我们中国从技术上、从能力上、从科学上都做好了准备，所以我们中国参与了全世界第二次探月高潮的 队伍里头。
On January the 23rd, 2004, the journey began. China officially initiated its lunar exploration program, named the Chang'e Project.
所以我们的规划里面，我们奔月亮的，是奔着我们要具备航天的能力，而且要凝聚成工程，表达我们航天的能力啊。就中国从探月1号开始，我们进入了一个深空探测的时代。
4、3、2、1，点火！点火！
In 2007, China's first lunar probe, Chang'e 1, was launched. It successfully entered lunar orbit and captured a full moon map with a resolution of 120 meters. In 2010, Chang'e 2 visited the moon and obtained the full moon map with the highest global resolution of 7 meters. A historic moment arrived in 2013, when Chang'e 3 achieved China's first soft landing on the moon, delivering China's first lunar rover. This marked the first time in 37 years that humanity achieved a soft landing on the lunar surface. China became the third country to send a spacecraft to the moon's surface.
中国的探月工程要起步晚，起点高。嫦娥1号实现了环月探测，嫦娥2号实现了7米分辨率的全月图。这个7米分辨率的高清全月图到目前为止还没人突破。嫦娥3号实现了在月球安全精确的无人着陆，嫦娥4号呢实现了在月球背面着陆，这是对世界的贡献。
In 2017, the China National Space Administration announced a new lunar mission, Chang'e 5, aimed at collecting lunar samples and returning them to Earth.
45 лет назад, 9 августа 1976 года, была запущена последняя советская автоматическая...
Since the Soviet Lunar 24 mission brought back 170.1 grams of lunar samples in 1976, humanity had not returned with any lunar soil. Could China succeed this time? China aims to be the third country after the United States and Soviet Union to collect lunar samples. The task of retrieving moon soil entails numerous challenges, with a launch vehicle playing a crucial role. The Chang'e 5 mission is marked about its complexity, leading to a probe that is larger, heavier, and more sophisticated. The Chang'e 5 probe weighs 8.2 tons, necessitating a high-thrust rocket for deep space exploration. In 2006, China began developing such a launch vehicle.
长火箭它是中国的新一代运载火箭，当时立项之初就是瞄着要打空间站，要登月球是吧？要探月、探火，还有我们未来走向更深空的这么一些探索之旅的这么一个火箭，所以说它一开始的时候就被赋予了这样的一个使命。
The Long March 5, China's latest high-thrust rocket, features a 2.5-stage design with 4 boosters, standing about 57 meters tall, with a 5-meter body diameter and 3.35-meter booster diameter. Each booster is powered by 2 120-ton liquid oxygen kerosene engines, totaling 8 engines across all boosters and producing a liftoff thrust of over 1,000 tons. It can carry 25 tons to near-Earth orbit and 14 tons to geostationary transfer orbit. The Long March 5 ranks among the world's leading active launch vehicles for both high and low orbital missions.
In July 2020, Chang'e 5 left Beijing for Wenchang Space Launch Site. Following extensive testing, the probe will journey to the moon aboard China's most powerful rocket, marking a significant milestone in Chinese space history. This launch represents the start of China's first sample return mission from an extraterrestrial body and signals the new peak in China's 16-year lunar exploration effort. On the launch pad, the Long March 5 carrier rocket is ready to go.
30分钟，准备好。10、9、8、7、6、5、4、3、2、1，点火！起飞！
Aboard the Long March 5, the Chang'e 5 probe successfully entered the Moon-Earth transfer orbit. It now faces a series of unparalleled and complex tests: sample collection, lunar takeoff, rendezvous and docking, sample transfer, and return to Earth. The mission will cover a round-trip distance of over 800,000 kilometers and last more than 20 days.
我们对月球已经有个基本概貌的了解了，但是新的东西啊，都会带来对未知的挑战。嫦娥5号上光这个发动机就89台，动作非常多，执行机构很多。这个工程从一开始确定方案的时候，就确实是一个高风险的这个工程方案。
Space exploration is arguably the most complex endeavor undertaken by humans. The rockets and probes used for lunar exploration have thousands of components. Launch missions involve thousands of procedures, and the generated data is immeasurable. And even the tiniest mistake could be fatal. Even if the components and procedures are flawless, there are still numerous uncertainties in the deep space that can cause failure.
Between 1959 and 2017, humanity launched 132 lunar probes, achieving a success rate of around 50%. Even a small error could result in failure. The Beijing Aerospace Flight Control Center, among the world's most sophisticated, oversees command, dispatch, control, computation, data processing, and communication for China's lunar exploration. The success of Chang'e 5 and the management of any issues hinge on ground-based observations and instructions. Telemetry and control stations throughout China meticulously track Chang'e 5's every maneuver. All data is funneled to the Beijing Aerospace Flight Control Center, where final decisions are made. The mission's initial goal is the soft landing on the moon. Despite China's previous successful landings, the Chang'e 5's landing demands are notably more challenging and exacting.
经过约112小时的飞行， 嫦娥5号探测器顺利进入环月轨道。
着陆器和上升器控制进入了近月点约11公里、远月点190公里的环月椭圆轨道，为动力下降做好了准备。
On December the 1st, 2020, at 22:57, Chang'e 5 initiated its powered descent.
发动机开机，动力下降开始。
At 23:11, the Chang'e 5 probe landed in a pre-selected area with a smooth and precise touchdown, and the lunar surface sampling work is about to begin.
如果说碰到一点打不动的，钻取失败。对，只要是我们有分了10级的图，只要是在我们考虑的图范围之内，我们都能取着。
The Chang'e 5 lander worked on a lunar surface for a total of 48 hours. However, considering the launch window for the subsequent lunar ascent and a fuel constraints, the actual time available for sampling was only 19 hours.
Collecting lunar soil could be simply described as digging dirt, but the level of detail and complexity is equivalent to performing a remote surgery. Once the Chang'e 5 probe saddles, it cannot move. But nobody knows if there is enough soil to dig around or beneath the probe. To deal with that, Chang'e 5 carries 2 sets of sampling tools, providing 2 methods to obtain a more diverse range of lunar soil samples.
月球表面上的一个钻探啊，不管是我们还是别人，都是个非常艰难的一些工作。我记得这个苏联第一次上去钻的时候啊，他就钻了大概是几十克的一个月球样品，非常了不得的一个成就啊！就是我们希望我们能不能超过前人。
各号注意，我是北京。根据飞控现场决策，下面组织实施钻取采样，采用月壤预编程策略。
The drill slowly advances downward, 1 centimeter at a time. The composition of lunar soil is complex, and the temperature variations are extreme. These are challenges that a drill must overcome. The drill bit of the Chang'e 5 is made of a unique material and can penetrate rocks with a hardness level of 8, encompassing sandstone, limestone, and most granite. Constructed from a composite material with aluminum foundation, the drill rod offers wear resistance and a durability on par with steel.
我们不可能带很多种钻头，然后去月球表面，所以呢，我们必须设计一个对各种可能面临的这种钻进的一个对象都能适应的这种钻头。
有一申请发送，用地面进行。
碰到大石头，你光回转缺些。 它的是不足以给它破碎的。月球表面的这个重力啊，是地球重力的这个1/6，所以我们专门有一个电极，给它在月球表面，在这个低重力环境下，提供这个它需要的一种钻压力，就摁着它往下钻。
我是北京，钻进取芯正常结束3组条，下面组织实施机械臂展开至采样中间点。
The drilling work is completed, and the next task is to sample the lunar surface.
既有旋转动作，也有抬升的一些动作，7、8个动作吧。这么复杂的一些的操作里面，它没有使用任何一个传感器，全都是通过这个机械的精巧的设计，然后实现这些操作的非常的精巧。
机械臂运动至出月后抬升点，调整，正确举发出，明白。
Through a series of complex movements of the robotic arm, the lunar soil samples are carefully scooped up. In the end, a total of 1.731 kilograms of lunar soil is sealed in a container.
各号注意，嫦娥5探测器月面采样工作顺利结束。好，谢谢大家，谢谢大家。
At this point, Chang'e 5 has already spent 48 hours on the moon, and the launch window for takeoff from the lunar surface is fast approaching.
发动机开机，上升器月面起飞。
Chang'e 5. This time, the main goal of this mission is to collect the lunar sample and return to Earth. This is the biggest challenge in China's moon exploration history. It's hard enough to collect the lunar soil, and Chang'e 5 used an extremely complex approach to bring it back.
探测器的构型变化的非常的多，质量变化也特别大。在整个过程当中，我们这个探测器的构型大概有7种变化，就一直不停的在变。
In lunar orbit, a tiny probe is undertaking a task that seems impossible to accomplish. This represents a new technological endeavor by the Chinese in outer space, marking the first unmanned rendezvous and docking in lunar orbit.
That means the 4 components that made up Chang'e 5 probe need to constantly separate and combine in deep space, some 380,000 kilometers away from us. Why did the team choose such a complicated plan? After all, it's only to increase the chances there's something going wrong.
飞到月球那儿去，这是在嫦娥1、2、3、4都已经做过的了。嫦娥5应该说是它所有的这个气是一个全新的。从我们一开始，我们自力锁体，我们有起飞的时候8吨2的重量，一直到在返回的时候，以后就只剩下1吨多一点。有一个很大的决心，就是要推动中国的技术进步。过于保守的方案会被 pass 掉。
计划于5时42分两目标对接开始，轨道器和上升器将转入无控模式。
它轨道都有修正了。
40米每秒，40米每秒。
月球轨道对接呢，地面的支持能力是比较弱的，就是不能够提供一些辅助条件的情况下，我们要自主的去寻找它合适的对接条件。
航程报告，轨道器转最后平移靠拢。
轨道器转15米接近。
航程报告，轨道器对接开始。
After the successful docking of the orbiter and ascender, the container holding the lunar soil samples is transferred into the return capsule.
样品转移到位。
航程报告，返回系统舱盖关闭。
各号注意，我是北京。 样品转移正常完成。
From the rendezvous and docking to the transfer of samples, it took only 30 minutes. At last, the Chang'e 5 is set to return to its home. The Sizuwang Banner landing site, situated in central Inner Mongolia, spans more than 2,000 square kilometers and stands as China's key site for spacecraft landings. The site's vast open terrain and excellent visibility are ideal for spacecraft search. The Chang'e 5 return capsule will land here. The orbiter and return capsule begin to separate at an altitude of 5,000 kilometers from the Earth's surface. At this point, the return capsule travels at a speed of about 11 kilometers per second. Without effective deceleration, the return capsule will be burned up upon entering the atmosphere.
返回器转初次载入模式。
跳跃式载入返回技术，我们会穿出大气层，穿出大气层以后呢，我们会走一个抛物线，再降下来，然后进行第二次进入大气层，2次进入大气层，通过大气的相互的减速作用，把11公里每秒速度减到7公里每秒的速度。
各号注意，我是北京，下面通报返回器第2次落点预报，落点经度东经。 111度，向右分24秒，东经111度，111度25分52秒，落点纬度42度2分13秒。双手发目标，双手发现目标，回收4号发现目标，回收4号发现目标。
各号注意，我是回收3号，询问各号接收无源定位坐标情况。我是2号。
In the early hours of December 17, 2020, the Chang'e 5 performed a skip re-entry technique to bounce off the atmosphere before safely returning to Earth, landing in Siziwang Banner, Inner Mongolia. China's first extraterrestrial sample return mission was successfully completed.
我宣布，探月工程嫦娥5号任务圆满成功。
After 44 years, lunar soil has once again arrived on Earth.
12月17日，经过23天的漫长旅程，嫦娥5号月球探测器返回舱携带月球样品安全着陆，首次实现我国地外天体采样返回。
Like opening a window in a long closed room, the lunar soil brought back by Chang'e 5 has provided a new possibility for lunar research. And those researches seems to show us a vision of future space travel. Confirmed by the International Mineralogical Association, the Chang'e stone, discovered by Chinese scientists in lunar soil particles, has been identified as the completely new mineral. Previously undiscovered, this mineral represents the 6th new mineral found by humanity on the moon.
On January 18th, 2021, 1 month after the return of Chang'e 5 to Earth, the China National Space Administration released the regulations on lunar sample management for the first time to the public, encouraging international collaborative research in space science based on lunar samples and the international sharing of achievements.
2024 marks the 20th anniversary of China's lunar exploration project. Over the 2 decades, China's space endeavors have yielded significant achievements, overcoming challenges and securing impressive outcomes. From manned space missions to lunar sample return, from the Long March 5 to the Tiangong space station, all these successes paved the way for a grander future in space exploration.
A more ambitious plan is currently underway. The 4th phase of China's lunar exploration project is to establish the research station at the lunar South Pole. The first launch mission will be scheduled for 2024.
下一步，我们嫦娥6号要发射，就准备在月球背面去采样，实现月球背面采样返回。
嫦娥7号呢是在月球南极将近极点的地方进行着陆，主要任务呢就是月球南极的环境和资源的一个详细的一个勘察的一个工作。
The Phase 4 of China's lunar exploration will see the launch of the Chang'e 6, 7, and 8 probes, as well as the construction of an international lunar research station.
中国是第一个提出在南极建科研站的国家。我们嫦娥7号的主要目的就是要在月球南极能够找到水的存在。人类想在那边去短时间吸吸水是最重要的。嫦娥8号呢，也是准备飞到月球南极，然后和嫦娥7号呢，这2个航天器啊、着陆器啊、月球车这些就组成一个月球科研站在南极的一个基本型。
The research station at lunar South Pole is a large international scientific project, jointly established by multiple countries, international organizations, and scientific institutions.
像我们嫦娥7号，现在有20来个国家给我们就是申请要合作。
我们也应该团结更多的国家，让他们更多的参与我们的航天活动，一起享受成果，一起迈向深空，这是人类共同的一个事业。
As our capability for deep space exploration continues to grow, scientific activities on the moon are set to intensify.
特别是要建月球科研站，都要有一个跟地球一样的月球轨道的通讯导航星座。要发射鹊桥2号，它就是一个月轨卫星。同时，我们在这个鹊桥2号搭载了这个2颗小卫星，在月球轨道去验证通讯导航这样呢，为我们未来建星座就是打基础。
包括了就说是地月空间的那种通讯能力，就是为整个的探月以及深空探测提供相应的那种基础服务。
Envision a scenario where Chang'e's probes, U2 rovers, astronauts, and scientists are all on the moon. The boundary between ancient legends and scientific reality is becoming increasingly blurred. The flames from the ascending rockets illuminated the 380,000-kilometer journey between Earth and the moon.
The Mid-Autumn Festival, or the Moon Festival, is one of the most important festivals in China. Chinese believe that on the night of a mid-autumn, under a big, round moon, wherever you are, whatever the distance, all loved ones, family members, and friends will sense each other. Everyone likes to look up at the moon and let countless thoughts arise and flow. In a not-too-distant future, moon gazing could take on new meaning. China's lunar exploration program embarked with its own romantic legends, creating history with ambition. All these endeavors will continue to spread this romance into the farthest reaches of the vast universe.
Human exploration of space consistently fuels innovation in science and technology. China's lunar exploration project, inspired by ancient romantic legends, has ambitiously made its mark on history. This endeavor, in turn, will extend the essence of romance into the vast reaches of the universe.